The daily life of modern world is overwhelmed with large number and large variety of instruments that play their role residing either in the background or in forefront. May it be a speedometer or a laboratory type instrument or a health monitoring instrument, fuel filling machine, or even our dearest golden retriever acting as a sensing and measuring friend in environment. The question that still may knock us: how do we classify all such measuring instruments? The first approach of classification categorizes the instruments into primary and secondary. One example of a primary instrument is the tangent galvanometer. The current passing through its coil and the deflecting angle of needle bears a unique relationship involving Earth's magnetic field. This instrument needs no comparison of performance with any other similar instrument, hence the name primary instrument. The secondary instrument, on the other hand, requires comparison with the standard one, the process of comparison being called as calibration, a feature used in most of the instruments. The instrument can also be classified as analog or digital. The former measures quantity as a continuous variable taking up any value over a certain range. The latter takes up measurement in discrete steps of time and the value is quantized in discrete levels. The third approach of classification is based on the nature of operation that the instrument carries out on the measured signal. Accordingly, the instruments may be classified as indicating, integrating, and recording instrument. The measured value is directly visible over a screen or over a dial in terms of pointer deflection for indicating instruments. For integrating instruments, a quantity is dynamically sensed first, then it is integrated either over a short duration or over the running time incessantly. The result of integration is the desired quantity under measurement. This way, average speed of a car or bike is computed by integrating instantaneous speed over a short interval and then it is divided by the interval. For the measurement of energy, power is integrated continuously. Recording instrument keeps track of measured information either on analog media or on digital media. The analog media mean that the information is stored in the form of a dynamic graph with a pen-paper arrangement or a magnetic tape. The digital method of recording uses either a file in a software or in a memory directly as hardware. The recording may be displayed dynamically over a monitor. The fourth method of classification includes various physical effects that are utilized by the instruments as their operating principles. The magnetic effect works with a magnetic field interacting with another field produced by a voltage or current. Typically, a permanent magnet is used in such case for generating the magnetic field. Tangent galvanometer is one such example. The electrostatic effect employs the interaction between two electric fields to generate a driving force or torque. Electrostatic voltmeter is one example. In the effect of electromagnetic induction, a set of conductor needs to cut magnetic flux. This is possible when the conductor changes its position or the magnetic field varies with time. Finally, a force or torque is generated to drive the moving system of instruments. Indicating instruments of different type belong to such category. The thermal effect is based on the heating effect produced by a current in coil. The effect of chemical reaction in a medium is another principle for the operation of a class of instruments. DC ampere hour meter is one such example where the dynamics of the flow of electron is estimated in a chemical reaction. The optical effect uses the change in property of light in presence of a magnetic field, electric field, etc. The estimation of change measures the quantity responsible for such change. The effect of radiation prevailing in an invisible spectrum is used as operating principle of another type of instruments. Ultrasonic wave, infrared, radioactivity, etc. decide working of such instruments. The fifth classification is simply the varieties of applications where different instruments are employed. For example, ammeter, voltmeter, etc. used in single-phase or three-phase applications. A d'Arsonval galvanometer with illuminated spot moving over a scale is a special type, obviously. The sixth classification highlights the essential constructions required to generate deflecting or driving torque. In one case, there can have a permanent magnet and a moving coil. In a second case, the arrangement can have one fixed coil and one moving coil. Thirdly, one fixed coil accompanied with a piece of iron can serve the purpose. In integrating instruments like energy meter, two fixed coil and a rotating disc fulfills the requirement. The seventh classification encompasses a special segment of instruments. They are directly not the measuring instruments, but they assist in measurement by extending the range of normal instruments. If the measurand is of high value, it is stepped down by this class of instrument to the measurable range of other instruments. Eighth classification identifies the types of control torque employed. They can be spring control, gravity control, or suspension control. Ninth classification highlights the programmability of instruments. In case instruments are equipped with processors, the type of processor used dictates the feature programmability of instruments. While the single-purpose processor offers the limited scope of options to the users of instruments, the application-specific instruction set processor offers the options to a higher degree. Microcontrollers are the application-specific processors that can be programmed and sometimes reprogrammed. When reprogramming is open, it is performed by the designer of the instrument by changing source code. The user can enjoy the final product only, but with some liberty of altering the available options. Thus, the instruments can be either indirectly programmable with the ability of altering options or directly programmable by altering its source code. Tenth classification categorizes instruments on the basis of display that the instruments have. Either they can register some reading in different forms or only shows whether there is a null output present or not. Potentiometer is the example of the second case. Instruments can be self-operated when the actuating signal is drawn from measurand. When power operated, auxiliary power supply needs to be provided. Instruments can be of contact type or of non-contact type. Non-contact type instrument keeps itself separated from the measurand physically, but shows reading as usual. In 13th classification, instruments are either placed in the close proximity of the measurand or are operated keeping a distance away. In latter, a wired or wireless communication is required between the sensing system and monitoring system. The instruments can be mounted on a panel or are portable when its position can be changed freely as per the requirement. In 15th approach of classification, instruments can work independently or work keeping connected with other instruments, some supervisory controller and or server. Smart energy meter are such examples of networked instruments.